Greetings of the day. My name is Madhushri Wag and I am here with my co-authors Mayur, Amay, Pawan and our mentor Raviraj Joshi sir to present a paper on importance of layer pruning for smaller BERT models and low resource languages. Our paper ID is 60. Moving on, the agenda of today's presentation is that I would start by going through the background, then we will look at the problem statement and I would discuss the objectives. Background. Background refers to the past research that has been done in this field. Research has been done on transformer-based models like BERT, which stands for Bidirectional Encoder Representation from Transformers, and it has revolutionized NLP. It helps in tasks such as classification and text generation. However, it poses challenges for low resource languages and low resource tracks because despite the success of BERT, it has large model size and computational demands. It limits their deployment for languages like Marathi because Marathi has limited training data. The solution that we have come up for this problem is model compression techniques, particularly layer pruning. Layer pruning refers to removal of redundant layers and lowering the computational costs without compromising the performance. The problem statement overall is transformer based models are too large and resource intensive for low resource languages like Marathi. Multilingual models like BERT often struggle with language specific tasks, whereas training smaller models from scratch demands similar or significant resources. This creates a need for efficient methods like layer pruning, as we are doing in our project to optimize the large models for resource constrained settings without sacrificing the performance. Now, the objectives are our primary goal is to develop optimized smaller versions of BERT and Mural for Marathi language classification tasks using layer pruning strategies. The key focus areas are evaluating the effectiveness of pruning strategies. We are performing top pruning, middle pruning, and bottom pruning to maintain high accuracy across data sets of varying lengths. The data sets we are using are HHC, LPC, and LDC, and comparing pruned models to scratch trained smaller compact variants like Mahabhat Small. Key contributions. Key contributions include developing of efficient models, layer pruning with fine tuning yields high performance, and optimal strategies. Middle layer pruning, we observe that middle layer pruning balances efficiency and accuracy the best compared to top and bottom layer pruning. Then we do model comparisons. Monolingual models outperform multilingual ones, and pruned models outperform the scratch trained compact models. We are trying to develop a scalable approach, a cost effective method for adapting advanced NLP models in low resource tracks. Related work has been done in CNN pruning techniques, transformer based pruning, and indic NLP research. In CNN pruning techniques, weight pruning, structured pruning, feature representation based pruning reduces complexity. In transformer based model pruning, techniques like layer drop includes dropping of layers during training without fine tuning, and methods like quantization and knowledge distillation have been used to reduce memory and reduce computational costs. And indic NLP research includes Mural, and Mural, which stands for multilingual representation of Indian languages, which has been pre-trained on 17 Indian languages, and XLMR show promise for cross-lingual transfer, but it underperforms low resource tasks while Mahabhat outperforms them.